We are going to start multiplying rational expressions. So you should have just done simplifying and gotten some practice in with that. So we're just going to add an extra step. So really it's the same exact thing. So if you were good with simplifying, you are going to be just fine with multiplying as well. A few rules, really just one rule. When multiplying rational expressions, we are allowed to cancel vertically and we are allowed to cancel diagonally. Okay, vertically just means, and I'm going to write it underneath kind of small, top to bottom. Okay, which means the only way we are not allowed to cancel is horizontally. Okay, so what we're going to have now is we are going to have two different rational expressions that are multiplying, and our job is to do the exact same thing that we did when we simplified. We're going to factor everything that we're capable of factoring. We are going to find the domain, and then we're going to cancel however we can. Okay. Sometimes we're not going to be able to cancel anything. Sometimes we'll be able to cancel everything, and that's perfectly fine. So we just have to remember that horizontally, if they're on the same level, so top to top or bottom to bottom, we are not allowed to cancel there. Okay, in the note in the directions, I still want you working on interval notation. So we're still in the beginning stages of the chapter. Okay, so I want us getting practice with domain and interval notation. So when I look at number 1, if I look at that first expression, x minus 7 over x minus 1, there's nothing that I can factor in that. So I'm going to just rewrite this one. This one's going to stay the exact same. There's nothing I can do. The one on the right, when I look at the top, I can use difference of squares. So I get x plus 1, x minus 1. On the bottom, I can pull out a GCF, and I'm left with 3 parentheses x minus 7. Now everything is factored. So remember, we pause after we do that, and we're going to find the domain. So when I look at the bottoms, x can't equal 1, x can't equal 7, and we go least to greatest. So my domain for this one is going to be negative infinity to positive 1, 1 to 7, 7 to infinity. Once I get the domain, now I can start canceling things. Okay, so remember, top to top I can't cancel, bottom to bottom I can't cancel. I can cancel diagonally, so I can cancel the x minus 7s. Again, diagonally here, I can cancel there. So the only thing that I'm left with on the top is x plus 1. On the bottom, I'm left with that 3. Now, we have to be really careful. That 3 doesn't affect our domain at all. There's no variable with it. It's just a number. Anytime that happens, okay, when you have a GCF of just a number, that's not going to affect your domain at all. And those are your two final answers. So when I look at number 2, I can factor the top left. So I'm looking for factors of negative 8 that give me negative 2, which is going to be x minus 4, x plus 2. The bottom left, I can use difference of squares, x plus 1, x minus 1. And then I have to do the same thing for the one on the right. The top, there's nothing I can do. The bottom is going to be x plus 4, x minus 4. Now I look and make sure everything looks like it's all factored. I didn't miss anything. It does. So from here, I can go ahead and start working on the domain, okay, which we've got quite a bit here. So x can't equal negative 1 or positive 1. X can't equal negative 4 or positive 4. So this one's going to be pretty long, okay? So remember, we start least to greatest. So we're going to go negative 4 to negative 1, and then 1, and then 4. Okay, so we're going to have negative infinity to negative 4, negative 4 to negative 1, negative 1 to 1, 1 to 4, and then 4 to infinity. So super long, but it's okay. It's just because we have so many excluded values. Okay, so that's going to be our final answer for the domain. And then from here, I can start canceling. So my x minus 4's cancel. And that looks like it's it. So not a ton cancels here, which is fine. Okay, so remember to keep everything in parentheses when we write it all together. So the top is going to be x plus 2, x plus 3. The bottom is going to be x plus 1, x minus 1, and then x plus 4 as well. Okay, so again, longer answer, but that's perfectly fine. And you do not have to multiply everything out, so you are more than welcome to leave it in that form. I'm not going to make you sit there and FOIL everything on the top and FOIL everything on the bottom. Having it in factored form is perfectly fine. All right, moving on to number 3. Number 3 looks a little different. The first thing that I'm going to do when I see something like this, and I'm going to put this over 1. Okay, that way it looks like a fraction times a fraction, so it looks the same as what we've been dealing with for the last few. Okay, and then again, I just start to factor. So the top is going to factor x plus 9, x minus 9. Okay, the bottom, I'm going to look for factors of 81 that give me 18. Okay, numbers like this, I would probably give you a calculator. Okay, but this one's super easy. The main factor of 81 is 9 and 9, right? So now, because that 18 is negative, we have to be really careful. So this bottom is going to be x minus 9, x minus 9. If you needed to do that the long way, you would do this. So minus 9x plus 81, factor by grouping. And then you would end up with x minus 9 twice. Okay, so if you still need to do that long way, that's perfectly fine. Whatever gets you the right answer. Okay, now the top of the one on the right, the only thing I can do is pull out a GCF. So I'm going to pull out an x. And then I still got over 1, which remember, anytime we have just a number, that's not going to affect our domain. So we have x can't equal 9. This one ends up being the same. Okay, so we only have one value that it can't equal. So for our domain, it's just going to be positive 9. So negative infinity to 9, 9 to infinity. And then I can start canceling. So I have an x minus 9 here that cancels. And they only cancel one by one. Okay, so here I can cancel again because there's 2 on the top and 2 on the bottom. So then I am left with x plus 9 on the top multiplied with that x over 1, or you can just write it like this. I'll take either. Okay, go ahead and try the last 3 on your own. I would pause the video. Okay, go through, factor everything, cancel everything. Make sure you state the domain and interval notation. All right, so number 4. Okay, top left, I'm going to use SOAP. So it's going to be x plus 2, x squared minus 2x plus 4. I can't do anything on the bottom left. The top right, I'm looking for factors of 4 that give me negative 4. So that's going to be negative 2 and negative 2. So it's going to be x minus 2, x minus 2. The bottom right, factors of 4 that give us negative 2. So if we think about that, we've got 1 and 4, and we've got 4 and, or 2 and 2. None of these are going to give me negative 2. So that's not factorable, so we're just going to leave it. Okay, now, in a situation like that, we don't use it for our domain. I'm not going to make you do quadratic formula with this to find the domain. That would be aggressively mean. Okay, so the only thing, we're looking at real numbers. The only thing for our domain here is x cannot equal negative 2 or positive 2. So then my domain is going to be negative infinity to 2 to infinity. And then we can start canceling. So I have x minus 2 here. And then this trinomial actually cancels because it's the same thing that we got when we did SOAP. So the whole bottom cancels. So again, if you want to put it over when you can, I'm not going to. Your final answer simplified is going to be x plus 2, x minus 2. And this is our domain. Okay, number 5. Top left factors to x plus 4, x minus 1. Bottom left is going to be x plus 2, x plus 2. top right, I can pull out a GCF of 2x. And then the bottom right is going to be x minus 4, or x minus 3, x minus 1. Okay, stop and find your domain. So we have x can't equal -2, -2 again, so we don't have to list it twice, 3, and 1. Okay, so starting least to greatest, we're going to go -2 to 1 to 3. So it's going to be negative infinity to -2, -2 to 1, 1 to 3, and then 3 to infinity. And then from here we can cancel. So let's see, I've got x plus 1, or the x plus 2, the x minus 1, and I think that's it. So the top is going to be 2x and then x plus 4. The bottom, it's a really bad 4. The bottom is going to be x plus 2, x minus 3, and that should be our final answer. All right, and then the very last one, okay, again, everything should start feeling repetitive. It's the same process, same thing. And like I said, it's a lot of factoring, and this whole chapter is going to be. Okay, so the top left, factors of -6 that give us -1 is going to be x minus 3, x plus 2. I can't do anything with that bottom left. Top right, I can pull out a GCF of 2x. And then bottom right is going to be x plus 2, x plus 3. So then my domain, we have to be careful here. So remember when I said that it doesn't matter if we have a GCF that is a number. Here we have a GCF that has a variable with it. So we have x cannot equal 0. Anytime you have a variable that doesn't have a plus or minus, it's always going to be 0. X can't equal -2. X can't equal -3. So then least to greatest, we're going to do negative infinity to -3, -3 to -2, -2 to 0, 0 to infinity. And then start canceling. So I can cancel one of the x's here. Only one of them. I have 1 on the top, 3 on the bottom, so I'm left with 2 on the bottom. I can cancel the x plus 2. And then this 2 and the 4, this can turn into 1. I can simplify these both by 2. So 2 over 4 is 1 over 2, right? So we are going to have x minus 3, x plus 1 on the top, over 2x squared, and then x plus 3 on the bottom. Okay, and if you wouldn't have noticed the 2 over 4 until this last step and then you canceled again, that would have been perfectly fine. And if that's something that you forget to do on a test or quiz, that would only be like -0.5, okay? Minus a very small amount because it's a small portion. But make sure that at the end, there's nothing else that we are capable of canceling.